Okay, class, welcome to the next math lesson in Eureka Math Module 2. This is Lesson 4, and Lesson 4 is about something called reflections. Now, this is not the type of reflection we do in language arts, where you think back on your connections or how you feel about a certain text. This is something different for math. You will need pages 31 through 41 in your Math Module 2 books. You also need the normal things, paper for notes, so you can take notes with me. You might want more than one color of pen, like I use, just to highlight different things and make things stand out. You will also need your transparency or a piece of plastic to help you with the reflections and the transformations, and some kind of marker that you can erase off the piece of plastic. Other things that might help you are a ruler or something with a straight edge, and if you have it, maybe a protractor, although you will not necessarily need a protractor today. They just recommend it, but we can do without. So let us talk about the road so far. Remember, if you need to pause the video at any time, you can pause the video whenever you want. You can rewind the video, go back and watch something for more clarification. If you are pretty sure you understand something, you can even skip ahead of the video, but always check for your own understanding and make sure you understand the concepts. So far in Module 2, we have talked about three types of rigid motions. Three types of rigid motions. Remember, rigid motions are transformations or also changes in a figure that keep congruence. That is what a rigid motion is. And remember, congruence is same size and shape. So rigid motions are changes that keep the same size and shape. Changes that do not change size and shape. Usually they change location, where the shape is. Now we talked about the common language for these. We said that there's a slide, a flip, and a spin. Now the slide we talked about in lessons 2 and 3 are also called translations. A slide is a translation. And the rule for a slide, how the translation works, it uses something called a vector that shows direction and distance. So a slide is also a translation, and it uses a vector. Today we're going to talk about rigid motion 2, the flip. So let's take some notes about what it means to flip a figure. So today, let's look at the flip. Now the flip, just like slide is also called a translation, the technical term for a flip is a reflection. Reflection, yes, that's where the name of the lesson comes from. Now, a translation uses a vector, but a reflection does not. Reflections do not use vectors. They use a different rule. Vectors are rules for translations. Reflections use something called a line of reflection. That's the vocabulary word for today, a line of reflection. This line of reflection is what the figure flips over. use a line of reflection that a figure flips over. The line of reflection tells us where the flip happens. Just like the vector tells us where the slide happens, the line of reflection tells us where the flip happens. So one way to think of a reflection like this is think of a mirror. Think of a mirror. Think of a mirror that a figure is looking into. So today we're going to pretend that our figures, that our shapes are looking in mirrors. The line of reflection is like the mirror. So what you have is you have something looking in the mirror and something looking back. And in the middle is the mirror. So you have the original figure. Let's draw something here. Let's draw, let's do R for reflection. Let's say R just got out of the shower looking in the mirror. And the green is going to be our mirror. On the other side of the mirror, R is reflected. So this is the original, this is the line of reflection, the mirror, and this is the new one. We're going to be doing the same thing. We're just flipping something over a line. It's like you looking at a mirror in your bathroom where you hold up your right hand, but the mirror looks like it's holding up its left hand. Let's explore a little bit this because it's kind of hard to explain without examples. So let's look at some examples of this starting on page 31. Page 31, hopefully you can see this. It's a little bit faded on my copy, but you should be able to see it at least on your copy here. Let me make it a little darker for you so it's easier to see. Or maybe I'm just old and I need to make it easier for me to see. So we have triangle ABC, we have figure D, and we have a line of reflection. This L is the line of reflection. So you should be able to see that in your book. Now what it says is reflect triangle ABC and figure D across line L. So we need to find our rule. The rule is the line of reflection. And so line L is our rule. That's what everything's going to flip over. So to do this, to do the flip, you need your transparency. You can kind of see mine if I wiggle it, but I'm going to put it exactly on top of the paper, and I'm going to trace everything with my dry erase marker. So I'm going to get a few different colors just because we like colors. So my line of reflection is L. Very important that you draw the line of reflection right here. Start with your rule. There's my rule. Now I'm going to trace the triangle ABC. And I traced it in green. And I'm going to trace figure D in blue. There we go. So now I have everything traced. Now the reflection, remember, think of it like a flip. It flips over the line. So let's lift up the transparency and flip it over the line. So the line stays in the same place, but everything gets flipped. Do you see how it looks like the triangle and figure D are looking in the mirror? That's what it should look like to you. It looks like a mirror image. Now, to do this, make sure your line is in the same place, and then we get the fun game of trying to write on the paper underneath the transparency, which I'm just going to do the 3 points of my triangle because I can connect them later. And for figure D, it might be a little bit more tricky because it is a curved figure, so sometimes that can be tricky. Just do your best. And then to help me, I'm going to get my ruler to help me with this. You can use a ruler, you can use anything with a straight edge will work. So that is going to be right down here. This is what we call figure D prime because it is the reflection. It is not the original, so we label it as D prime. The D is over here, so this is D prime. And then triangle ABC prime, I need to connect my dots as precisely as I can. And that is what I have. This turns into A prime, this turns into C prime, and B actually did not change. So it's not B prime because B did not move. It's only A prime if it moves. A moved, so it's A prime. C moved, so it's C prime. B is still B, it's the same spot. So that is practicing our reflections with our transparency. Hopefully you did that as well, and yours looks pretty close to mine. Ideally, all of ours would look exactly the same, but there might be some differences depending on what moves and what shifts when you're trying to write things down underneath the transparency. But that is what a reflection looks like. It looks like this triangle and this figure were looking in the mirror, and the L is the mirror. So in the mirror, it's flipped, and in this side of the mirror, that's flipped. So a reflection is just flipping over a line. A reflection is flipping over a line. And hopefully you saw how we did that with the transparency. Number 2 is asking a question. Which figures were not moved to a new location? So what stayed the same? Well, we already know that point B stayed the same. Point B did not move. It's in the same spot. The other figure, line L, did not move. The line of reflection does not move. That's a the line does not move. The line of reflection stays in the same place. So point B and the line of reflection stay in the same place, line L. The reason point B did not move is because point B is on the line of reflection. Point B is on L, so it does not move. So anything on the line will not move. But everything that was off the line, A, C, and all of D, those did move because those were off the line. So let's practice some more because I think you're getting it, but I want to make sure. Go to page 32. And on page 32, you'll see more reflection practice. Always remember to find your reflection, your line of reflection first, your rule. And it says reflect the images across line L. So we are flipping over line L. So line L goes straight down the page right here. So we need to reflect across line L, which means flip over line L, and then label the images. So we need to get our transparency again. I already cleaned mine off when you weren't looking. And for line L, I'm going to, remember, always do your rule first. So line L is my rule. That's what I'm flipping over. So I'm going to trace that first and label it line L. Next, I'm going to do, we need to reflect the circle. So and that has circle with segment IJ. So I'm going to trace the circle. And just to help me out, I'm going to add dots for I and J. I traced in one color. I'm adding the dots in another color because those are separate from the circle. And we need this angle ABC. So let's trace angle ABC and label ABC. And now, after everything is ready, we are ready to reflect. We are ready to flip. So we flip over, making sure our line of reflection stays in the same place. So we flip it. You see how it's backwards now? It's reflected, and the line of reflection stays in the same place. Now I am ready to do my best to trace these, to transfer them onto the paper. So I'm going to try to keep it the same and kind of sneak under for C, for A, and for B. And it looks like I got those points pretty good. Then I'm going to try to do this circle with J and I. And I'm going to do a few more points on the circle, hopefully to be able to make a pretty good circle. This is tough to do by hand. Later in the module, we will probably look at some computer programs that make this easier, but right now we're practicing doing it by hand. So if you see, I'm doing some quick little dots, trying to get close. That's what I care about. I care about you getting close to this. Perfection is not what we need to do. Right now we're just working on the idea. Now let us try our best to fill in the gaps that we made doing that. So our circle is going to go right here. That's about, hopefully you might be a little bit more artistic than me, can do better than that. And do not forget I and J and their connecting segment. So this is J prime, because that's where J was. If you remember when I flipped it like this, J was right here. This is I prime. And then this is the image of the reflection of angle ABC. So this is the image of the reflection, and we need to label this too. So this up here is going to be A prime. This is going to be B prime. This is going to be C prime. So we are ready. We did the reflection. It looks pretty good to me, and I'm happy with it. So that's how the transparency can help us. That's how we do reflections with transparency. It is a little bit tricky writing under the transparency. Remember, another option is to kind of put your phone underneath the paper. Maybe on the next practice one, we'll do that, so I can show you that strategy. But let's answer the questions about number 3. Number 4, use a protractor to measure the reflected ABC. Well, let's just use our logic here. In lessons 1 and 2, we learned that rigid motions do not change size or shape. A reflection is a rigid motion, so we know just flipping it does not change size or shape. So this angle right here is not going to change. This is still going to be 66 degrees because reflections do not change size or shape. So for 4A, what's the measure going to be? 66 degrees. So the measure of ABC, the angle ABC, equals the angle of A prime, B prime, C prime, because reflections do not change size or shape. That is the definition of a rigid motion. For part B, use a ruler to measure IJ and I prime, J prime. This I can do. That looks like 1.5 centimeters, and this also looks like, well, it looks like maybe 1.7 centimeters for both. About 1.7 centimeters. If I measure it with inches, I like 1.7 centimeters better. So both of these are about 1.7 centimeters. They called it 5 units. But the length of both of them, ij equals about 1.7 centimeters. I prime j prime equals 1.7 centimeters. So you know ij equals segment ij equals segment I prime j prime. But you're not surprised at that because you know reflections do not change size or shape. They're rigid motions. Size and shape do not change. So you already knew it wasn't going to be different. They're just trying to prove that by lots of examples. Looking at number 5 now on page 33. Reflect figure R and triangle EFG across line L. So our rule for this one, our line of reflection is line L. So we're going to reflect it and then label it. So we are flipping over line L. So let me get my transparency, which again, I cleaned off without you when you weren't looking. I'm going to label my line of reflection first, because that is where I'm flipping. And then I'm going to trace the figures that I am flipping. So I'm tracing figure R, which is this half circle. I'm just going to put R in the middle. And I'm reflecting triangle EFG. So I'm going to trace triangle EFG, and I'm going to label E, F, and G. Now we're ready to reflect over the line. We're going to flip over the line. And I told you that I was going to try to do this for you with the light method instead of trying to reach under the transparency method. So let me turn on my light. So my light is right there. Maybe it's blinding you a little bit right now. And I'm going to flip it. And I'm going to flip it like that. Only this time I'm going to try to sneak it under the page. So hopefully you might be able to see that. I can see it, but I don't know how good the camera is. Where you see how my pink line of reflection is underneath the original line. And then you could see like, oh, there's the triangle. So let me put the triangle on the paper. And now let me move the light over to the semicircle, and that is where that goes. So this is going to be R prime. And this is going to be E prime, F prime, G prime. So that's another way to do it. Instead of writing underneath the transparency, you can kind of put a light underneath the paper and try to see through it. It is another strategy. It is, again, not super easy. It is a little bit tricky. But if you like that way better, do it that way. Because now when the transparency is gone, you can see the reflections. I'm just going to connect the dots on my reflected triangle real fast so that it is easier to see. And I'm going to make my reflected semicircle a little bit darker so it's easier for you to see. And you can see how the reflection works. And this was a fun one because we got to make the triangles crossed when they reflected. So hopefully you're able to picture this a little bit in your mind. Hopefully it's working out for you a little bit. And you are figuring out how to use your transparency to do this. Because I enjoy this. This is like little puzzles, little activities. Instead of making lists of equations and doing a lot of multiplication, addition, division, and subtraction, I'm just drawing pictures. And I just have to figure out how to draw the pictures. It's a lot of fun for me. Okay, so that's page 33. Let's go to page 34, which is a little bit more practice, and this is also kind of hard to see. So look at yours, and I will try to work on mine. So what I'd like you to do right now, look at the picture, because this already has the reflection. So let me make mine a little bit darker, easier for you to see. So that's my line of reflection. And if you look on the line of reflection is a point D. And then we have an angle right here, angle ABC is right there with an angle. And it looks like they reflected it over the line to make this right here. And on this side, they tell us the angle is 150 degrees. Hopefully you can see that. It looks like they also reflected a triangle. So here's the original triangle on this side. And this is triangle I, and I see a K. And on this side, the reflected one, hopefully you can see better than mine. We see J prime is right there. We see this is 7 units. We see this angle is 31 degrees. This angle is 28 degrees. And we also have a sector of a circle that they labeled figure A, and that this is 4 units. This is point F right here, and I believe this is point H. And that is what I have for my labels. So hopefully it's a little bit darker. So, and this one is going to be the image of A. So everything's a little bit darker, and I just talked you through the whole thing. So let's look at the questions now. Number 6, use the picture to label the unnamed points. Well, okay, here we go. Let's start with the angle ABC. If this is angle ABC and this got flipped over, then this right here is going to be C prime, because that's the, if we flip it over like that, this will be B prime, because that's where the angle is, and this is A prime. You notice they are both far away from the line of reflection. Triangle KI and J, well, here's J prime, which must mean the original J is right here. And this is the original I, so I prime must be right here, close to the line of reflection, because they're both close to the line. And then K prime is going to be over here, farther away from the line of reflection. And then we have the sector FH, so this is going to be, we have to figure out, this is going to be H prime right here, this is going to be F prime right here. I'm guessing this is going to be, because it's not used yet, we'll call that G prime and this G. So that is all the points labeled. Even D. You notice how I did not change D, because D is on the line of reflection, so D is always D. There is no D prime. So that was number 6. We had to label all the missing points with the primes or the originals. Number 7, what is the measure of angle JKI? Angle JKI, now when you're doing an angle, remember angle JKI, so the middle letter is the angle we're looking at. JKI means we're looking at JKI right here for number 7. Well, angle JKI right here is going to be the same as the reflection, because remember, reflections do not change size. They're rigid motions. So JKI equals JKI prime, so angle JKI is going to equal 31 degrees, because JKI prime is also 31 degrees. Angle KIJ, so now we need this one down here. Well, we look at the image. The image says it's 28 degrees. And because reflections do not change size, the new one's going to be 28 degrees. And angle ABC, not labeled, but the reflection is labeled. And because reflections do not change size, we know this one is also going to be 150 degrees, because the reflection is 150 degrees. They really want you to know that reflections do not change size. And they're going to ask you again for number 8. What is the length of segment reflection FH and IJ? So FH is 4, so the reflection F prime H prime will also be 4. And IJ, well, I prime J prime is 7, so IJ will also be 7. So F prime H prime has to be 4, and IJ segment has to be 7, because remember, reflections do not change size or shape. How do you know? You can write reflections do not change size. They are rigid motions. Now, number 9? What is the location of the reflection D? So the reflection of D, well, here's D. Where's the reflection? Well, D prime equals D because it's on the line of reflection. So you say reflection of D is at D because it's on the line of reflection. And it does not move if it's on the line of reflection. Hopefully you understood all that. If you need to see it again, watch it again, or reach out to me for some help, and I'll have more examples ready for you. On to page 35. 35 has the lesson summary, which I'll let you read on your own. Then there's the homework helper on page, I skipped page 37 because page 37 is your exit ticket that we're going to talk about at the end. So skip page 37 for right now. Go to page 39. That's the homework helper you can use for some additional help if you need to look at another example on your own. And then we have the lesson 4 problem set. Now, the lesson 4 problem set, here's what I want you to do. I did a bunch of examples for you. I want you to try the lesson 4 problem set on your own, but you will check your answers with my post online. I will post the answers online. Just click on the link for the answers, and you can see what the answers are to check your work against it later. So what you are going to do now, you're going to practice with the problem set and then check your work with mine by following the link. And then after you are sure you understand everything in the problem set, I would like you to go to page 37, your exit ticket, and do the exit ticket and take a picture of it with your Chromebook or with your phone camera and turn this in. Now, the exit ticket answers will not be online because, well, then you just copy my answers and get credit. So the problem set answers will be online. The exit ticket answers will not be. I'd like you to do both. Start with the problem set, check your work, and then when you're ready, try the exit ticket and then turn the exit ticket in for today's credit today. Have some fun with the transparencies. Have some fun reflecting things. And I will see you tomorrow for lesson 5.